Geometry and algebra, this chapter. It's called Analytic Geometry. So, it stopped working. So I had to go back to the wired version. Yeah, we had like 8 videos in a row, there was no sound. So we're good. It's back there picking me up hopefully. And actually, former students informed me that my microphone was not working, and then I used the new one. And about 10 minutes after the broadcast is over, hey, your microphone's working. These are seniors that graduated. I'm lost my mathematician. All right, so today basically we're going to be working with distance and midpoint formulas. Do you remember those?
No.
What? You're killing me. Okay, so that's right. You guys got shorted in math for a little bit, didn't you? Ouch. Why would that be an ouch? It's just a.
No, he's saying like because we switched teachers.
It's just a fact. It's not saying. You know, it's just the way it happened. Frank and I talked about it even last week. It's just, it was a bummer for you guys that happened, but that's the way it is. So if you want to find the distance between these 2 points.
The distance formula.
Yeah, it's the distance formula. So okay, that's the distance formula. It comes from the Pythagorean theorem. Like, I'm not going to take the time to show you. Does that look familiar?
Yes.
No. Okay, I will work an example. Unfortunately, it worked. I know you guys are crazy. I would love to see you try. Then I can get involved. Okay. Let's just throw a quick one up here. I'm going to give you those 2 points. What's the distance between them? It's a plug and chug, right? You just have to figure out what x1 and y1, x2 and y2 are.
Yeah, I don't know this whole fucking
Yeah. We were taking a test last hour and like blaring through the wall. What's x2? 5. x1? 1. Always, always, always in these math formulas, you will combine the x values. You're never going to put the y's together. It's a little tip. And y2 and y1 are 2 minus 4.
Okay, do we need practice at the movement? Yes.
Here in about 5 minutes we will. It will prove very easy. So we have 4 squared is 16, right? And negative 2 squared is positive 4. You shouldn't get a negative root for distance. The nice thing about geometry is we don't work in negative numbers very often. So square root of 20 is your distance. Approximation on a decimal, anybody? So the calculator said? I would have guessed 4.5. Damon.
Wouldn't the square and the square root cancel out?
Ah, excellent question. No. Why?
We're adding, right? But
That little monster right there
oh
doesn't
my
allow us
God.
to do
Just
that.
told us that on the test. I was still going to cancel and that wasn't going to work.
That's what we call an algebra atrocity.
I do that.
Do not cancel these out. There's an addition between them.
You don't cancel out.
okay? The only time you can cancel is
multiplication. Can't you only cancel non-divisible signs?
if that occurs, right? Because the whole quantity is squared.
Yeah.
Or,
Oh, okay.
that you can cancel the squares because these are multiplied.
Right, you can't do it.
Yeah, but do not add addition or subtraction here. It splits those up. No touchy. Okay. Thanks, Crisco. The other part of today is the midpoint formula. Oh, I think I remember the middle point, right? It is a point, so your format is always going to be in a point format. Yep. Okay. So it gives you kind of a nice clue there. Midpoint. You don't know how many times you see people screw that up. So. It's the average of the x's. So add and divide by 2. Average of the y's. Divide by 2. So, do you want me to work that through with the points that we have up there? Yeah. That's good. So the x coordinate of the midpoint is 5 plus 1 divided by 2. And the y is 2 plus 4 divided by 2. We agreed there, right? There's your good. So those are, again, those are the basic ones. I expect you to know that. I would have expected you to know that already if I've had a normal math work.
Is that a question? Are you gonna lose it?
Yes. So that's basic geometry in the coordinate plane. We're going to use this in the next level in more of an analytic sense. Or an application. Do you remember, and I asked this before,
Well, the natural
geometric shapes like triangles and quadrilaterals, you remember all the different types of those. So if I ask you, we have triangles.
Oh, okay.
Yeah, you can have the scalene,
Oh, yes, sir.
right?
Obtuse.
Isosceles, or equilateral. Those are all only based on side length, right? So a scalene triangle would be 3 different side lengths. Isosceles would have 2, and equilateral would be all. All 3 are the same, correct? Jog your memory here, hopefully.
Oh.
How could I prove, if I had a triangle, coordinate plane, how could I prove that it's equilateral?
Point would be
Using what we just talked about. This is formula. 3 times, if they're all the same, you have yourself an equilateral triangle. I'm going to show you one here in a minute, but, so those are all possibilities, right? About quadrilaterals.
It has 4 sides.
There are 6 or 7. We could kind of organize it a little bit based on features. One side, 4 of the quadrilaterals are related to a parallelogram. So there are 4 different types of parallelograms. One is a parallelogram. Do you remember what that is? How would I show those sides are parallel?
With the little lines.
Midpoint.
That makes it easy.
Well, you
Distance does not determine if these are parallel.
You have to find the equation of the line.
Well, it's not that complicated, but you could do that. All you need is a slope. Okay, so you're going to be using the slope formula possibly, right? Which you already know. That I know. You can split the parallelogram into a rectangle. How am I going to prove something's a rectangle? Yeah, that's a property of parallelogram, right? So it is a property of rectangle as well. You're going to have to prove these sides are perpendicular to slope.
Oh, I see where you're going with
Well,
this.
not angle.
But
Well, not the angle.
you'll have to, well, I said the sides are perpendicular, the angles are 90 degrees. Same thing. Okay, so that would be one way to use to prove a rectangle. A rhombus. What's unique about a rhombus? Yeah, in some way, shape, or form. It's a parallelogram with 4 congruent sides. Okay. It's very similar to a square, it just doesn't have 90-degree angles. And then the last one is a square. It's a square, baby.
A square can be both classified as rhombus and rectangle.
It is both, it has properties of a rectangle and of a rhombus, yeah, so that's 4 of them. Those are probably the 4 we'll see the most. Okay. What are the other quadrilaterals?
Trapezoid.
Okay, trapezoid. Which we probably will not touch much, but top and bottom are parallel, that's the only condition. And they're not the same length, it has to be, okay, otherwise it would be a parallelogram. And what else? We'll fly a kite, man.
Isn't that a rhombus?
There's a kite.
That's like actual geometric name for it?
Yeah, it's a name, that's the name for it.
Wow.
Okay, go fly a kite, right? Yay.
Trapezoid,
Happy.
the sides are the same though, right?
Don't say your thoughts to that.
Right, aren't they?
That's a big column.
Just there aren't on the
So those are the shapes that we'll be dealing with.
Are those lines marked,
No, it's just a little.
okay, that one.
Just there aren't the sides on the trapezoid are the same though, right?
These two?
Yeah.
Not necessarily. If these two sides are the same, it's called an isosceles
Okay.
trapezoid. Yeah.
So it has to be the top and the bottom.
So thinking distance, midpoint, and slope, using those conditions to prove these different shapes. You got some calculating. So does that kind of ring a bell? Refresh your memory. All right. Let's determine. Okay. quadrilateral. Oh, what's a good quadrilateral mean? Four-letter words. Oh, come on. That's 3.
Four.
D says.
Brain.
F-O-U-R.
ABCDs was in the book. Oh, there you go.
Oh my.
Each letter is going to have a, you remember how to name quadrilateral?
No.
Each point has a letter that associates with it. So I guess this will show you. Let's see, 3, 2, and O is going to be 2, negative 4, U, negative 2, negative 3, and R is negative 3. Determine if quadrilateral 4 with these points is a parallelogram.
So whenever they say parallelogram, does that mean it could be also, it could be an actual like true parallelogram, rectangle, rhombus, or square?
No, it's specific to that.
Okay.
So you're looking yes or no, basically, right? I find it very helpful to graph these. If you graph them, you have to be really accurate because it can throw you off. Right, so point F, and then O, U, and R. There's your shape. So this can help you say possibly yes. Does it kind of look like a parallelogram? It could be a parallelogram, right? Yeah. So now we can do the math. If you look at this picture and it has no chance of being a parallelogram, you can say no, it's not a parallelogram because yeah, so to prove this is a parallelogram, we have to use slope, instead. Right? So what is the slope? Remember slope is n of side FO. This notation is very common in math, in science really. The slope of side FO. You've graphed it, so you can do right number one, which, right? 1, 2, 3, 4, 5, 6. Left 1. You can count. You got graph paper, you're good there, right? You could also use the slope formula. Same answer. Doesn't matter. Take your pick. That's FO. Okay, that's the slope. We're trying to turn parallel. Slope. Remember, you got your slope. Intercept formula. How you doing, Alex? What is wish I had to stand up and meetings all day. Okay, what's the slope of OU? Negative OU. That one. OU.
Oh.
And again, you can use the slope formula using some if you need, but graphing it makes it easier. And then the slope of UR. difference between saying, yeah, it looks like a parallelogram versus saying it's definitely a parallelogram. So you want to write kind of a statement here. Since have you seen that notation before?
Yeah.
Anybody want to translate?
Parallel line, FO is
Second FO is parallel to UR. You can write that out if you want in English. It's just shorterhand this way, it saves you time. Okay, since FO and UR are parallel, and OU and RF the quadrilateral is a parallelogram. Get used to writing statements like this.
Do I have to do that?
How many seniors do we have in here? One?
Yeah.
Okay, you wish.
Oh, where's that?
Andrew,
We have one senior in here.
What about Andrew?
We have one senior in here.
Ah!
We have one senior in this class.
What?
The rest of you will be in an AP math class next year. These are the types of statements you need to write.
I don't have to do that now or anything, right?
So start now. This is what I expected you to do. All right? Get used to it.
Wait, so was it right? Did you drop this class?
I have no comment on the matter. We have one senior in this classroom. There's not enough. I could probably sit here for 2 hours and go through every single situation I might run into. So you got to kind of think. You have to problem solve. Okay. Now so let's talk about other situations that might occur here. Since I'm not going to show them all to you. How would I show that this is a rectangle if it is a rectangle?
They have the same size. They're equal.
Okay, so this is kind of what you're going to have to do without me sitting there, without me showing it to you. I've shown you how to do a parallelogram with slope, right?
Yeah.
For the rectangle, what conditions are there? Opposite sides are parallel and congruent, and the angles are 90 degrees. Do I have to show all three of those?
No.
Actually. For a rectangle, what's interesting, all you have to do for a rectangle is show that all the sides are perpendicular. If all four angles are 90, you have a rectangle. It might be a square. So show the sides are perpendicular.
What's the shorthand symbol for perpendicular?
It's a slide, they put it upside down.
Okay.
There, right there.
Thank you.
Okay. Show the sides are perpendicular with slope. That one is in fact a rectangle as well. No.
No,
It's not. These are not negative reciprocals. That would have to be, this right here would have to be negative 1/6 for that to be a rectangle. So this is not a rectangle. Yes, you're comparing those to see if they're perpendicular. Okay, you can move on to a square, right? A square would have to have 90-degree angles, and the opposite sides would all have to be the same length. You're using distance formula, right? So, again, I can't show you every one of those. We'd be here all day. I'm sure you would love that as much as I would.
So if I'm able to just find two of the lines that are perpendicular to each other and they're two of the lines that have distance, is it possible that that's all I need, or do I have to go with everything?
For a rectangle,
Yeah.
you could show,
Like with the rectangle and the square, because they're the same. You just need to find the side.
for a rectangle, there are a lot of ways to tackle this one. You could show that it has one 90-degree angle and the opposite sides if you drew it in a rectangle.
Okay.
Okay, you could show opposite sides are parallel and there's one 90-degree angle, you have a rectangle. There are ways to minimize your workload. I encourage you to investigate those. Okay, but for a rectangle, I would not show parallel or perpendiculars, and I would not calculate the distance formula 4 times. You've got 12 calculations there that are unnecessary. Okay, so try to minimize what you're doing there. If this were a rectangle, these two lines would have to be perpendicular, correct? If I look at the slope of those two lines, remember they have to be negative reciprocals. So it would be negative 1/6, which this is not. Okay.
So I could use either method though, right? I could use the distance
Yeah,
formula or the
there are
slope.
different ways to solve these problems. All right? The point is, are you using correct reasoning in math to prove this is a parallelogram or a rectangle or a square, etc.? Again, you're going to be using the midpoint a little bit here and there. But most of your problems are this type or application. Like if you have a map with a grid on it, how far are 2 points away from each other using scale? I mean, that's one application. So I want to get your work and see if I can ask questions. Go ahead and hand up. Let me give you your work. We'll move on. You don't have to do this on graph paper unless you're graphing